Hey, so let's get started. Good morning, good evening, everyone. Thank you for being here. I'm really excited about this conversation on securing the autonomous future. Uh, I just want to get start with a simple but profound questions. When your car makes an independent decision, like when your factory robot does some self-correction, or when your digital assistant acts on your behalf while you are sleeping, uh, then who does you trust more, the system or the people who built it? So that question is the heart of everything we are going to talk about today. My name is Samaresh. I'm a principal engineer at HP. Uh, and basic, so I'm located in Austin. Here is a quick bit about me. As I said, I'm located in Austin. I have over 21 years of experience in uh, AI, ML, distributed system, and Edge AI. I did masters from Colorado Technical Universities in University and BTech from Kalyan University in India. My expertise is in agentic AI, Edge AI, IoT, security, cloud, and modern C++. I also have, good hands-on on Python and Golang. So, uh, so that is about me. Let's go further. And here is the agenda of our talk today: security, trust, accountability, human well-being. In next 25 minutes, we will talk about uh, the scale of the challenges. Nowadays, we have 80 billion IoT devices. All of them, or mostly all of them, uses some sort of autonomous AI agent. Then I will go to the core question, core questions. Here, what we will talk about is, uh, how how the means how do we serve the uh, uh, like how human beings are served, and uh, then the threat landscape. Here we are going to talk about the different attack vectors, a real incident, OWASP, agentic top 10 that was discovered last year, December 2025. They listed down top 10 threats into the agentic AI field, because that was kind of emerging. Agentic AI was one of the emerging field in AI. Fourth one is the architecture for the trust. Here we will discuss about the architecture, five-layer zero trust architecture we will talk about. Uh, and then we will talk about the security, how security will be handled, and then innovations for well-being. Next. So, uh, let's start with the number, this, uh, they set the stage for everything. As I said earlier, we have 18 billion plus connected devices, IoT devices globally, I mean. And by 2030, we will have more than 40 billions uh, devices available globally. And here we can see 33% of enterprise app with agentic AI by 2028. So that will be the increase in agentic AI app we are going to expect. And then here we will see 88% or organizations have confirmed that AI agent have some sort of incident or attack. So below you can see the connected devices ecosystems. Each has some sort of potential attack. First one is the Internet of Things, Internet of Medical Things, the left one. And then we have industrial OT ICS that is also exposed to some sort of attacks. connected vehicles, smart buildings, smart cities, edge compute, uh, cloud connected devices, and non-human intelligence. That is, we call it AI agent. So why it is going one step forward? So the question, what is the question at the core? So first is trust, safety, accountability, and being. So the, so I want to tell you from the number for a moment, because I think the most important is how can we create intelligent system that are both secure and trusted, right? So here we can see we have three pillars: trusting people with technology, ensuring human safety, and providing accountability. So first dimension talks about when AI agent acts on your behalf, invisibly at the speed of machine, you need to be able to trust it, not because you have, you know about the architecture and all, but it's because the system was designed uh, with the trust, as a first class requirement. uh, Second one, ensuring human safety, is where uh, here I mean the physical safety, right? When where AI meets the IoT world, we are not talking about the data. We are talking about the medical devices that keeps people alive. Uh, Power grid that heat our homes, vehicle carrying our families or passengers. A security failure in that world is not a data breach, but it can cost a life. So AI with the IoT can affect the physical world, medical device, power grid, vehicle, anything you can think of. Breach is not just a data loss, but it can cost life. So we should focus on safety design. And the last pillar is provisioning accountability. Uh, this is the third, this is where autonomous agent makes an harmful decision. Like, let's say if some of the autonomous agent makes a harmful decision, then who will be responsible for that? There there should be some clear answer, right? So every autonomous action needs some sort of traceability, audit trail, and human oversight at the critical decision point. So uh, you know you might have seen that, Tesla autonomous car, right? So when you drive the Tesla in the autonomous mode, and if something wrong happens, Tesla is no autonomous driving feature is not will not be accountable for that. It will be the driver who is sitting in the car or in the driver's seat. So so these three pillar at the end, I will say trust, safety, accountability are the lens through which I want you to evaluate everything else I will show you today. So here are the threat landscape. That is this correct one? Yes. So this is the threat landscape we have observed in 2025, and now we are same trend is going to continue in 2026. When the autonomous AI meets the insecure IoT devices, then like when that happens, you will see the growth in the threats, or security is about 43% in healthcare IoT sectors. Energy sector have 90% growth. Manufacturing has 6%. Educational IoT has I think I was wrong. Educational IoT have 43%, healthcare have 11%, transportation has 19% and OT ransomware has 2% increase. On the right side here, you can see 1 in every 3 data breaches involves an IoT devices, right? And 92% multi-turn prompt injection is the success rate. That is really risky. Uh, uh, $10 million average cost on uh, I, medical IoT device breach in the healthcare sector, and 50% IoT devices with the critical exploitation vulnerabilities we see. So this is the OWASP top agentic AI threats that I was talking in the first page. So, so this is this is an agency. We call it uh, you know uh, worldwide security project something is the name of that agency. Out of those 10 we are going to talk about the first 6. First one is the prompt injection, second is the memory poisoning, third one is the tool misuse that happens when we deal with the MCP protocol or MCP server. Fourth one is agent hijacking. Fifth one is non-human intelligence privilege abuse, and sixth one is the supply chain tampering. Uh, Now we will talk about anatomy of a real-world AI agent attack. Here we will talk about the MCP server compromises, agent hijacking, and silent data exfiltration. So these are the five steps I have documented. First one is the initial foothill. Uh, it starts with the GitHub issue. The attacker embeds hidden instructions inside what looks like a legitimate bug report, but the text is crafted to be processed by intelligence agent that is integrated with the repository via Model Context Protocol MCP. Second one here is the injection where AI agent reads the issue, which that is his exact job. The hidden prompt overrides is system instruction. The agent now believes that it is following the legitimate command from its operator, but ideally it is not. It has been hijacked. Third one, you can see the pivot. Uh, Using it, it's a perfectly legitimate access. So it uses the legitimate access token. The agent moves literally into the cloud storage, onto the database, onto the connected services. Fourth one is the exfiltration. Sensitive IP and credentials are equally copied to the attackers. Uh, Control endpoint. The agent is still runs normally, monitors the tools, uh, all monitoring tools, or whatever data monitoring tool is looks green at this stage. Then last one is uh, persistence. Here the here we see the memory poisoning that ensures the malicious instruction survives the session even after resets or restart. The next time the agent runs a day or week later, but still it will be compromised. So so this is the architecture diagram what I have followed to implement the security checkpoints in my organization. Uh, so at the so it has a 5 layer of security. It starts from the top to and goes to the bottom. So on the top level, you see the IoT device ecosystems. Here we will have a security camera, drone, UAV, smart light, industrial robot, GPU, accelerator, TPU, medical sensors, smart meter, etc. Uh, so, and then at the second layer, we have zero trust fabric. So this is the kind of gatekeeper layer. before any uh, data from layer one can be processed, it must pass through some sort of security checkpoints. So these are the security checkpoint, non-human intelligence, IAM, mutual TLS, OODA policy engine, network micro-segmentation, AI-powered UBA, and then the cryptography. Third layer is the brain of this system. We call it agentic AI security at core. So here at the middle, you see the agentic AI orchestrator that talks to all the AI agent, compliance, behavior, response, and intelligence, and then and takes the autonomous decision, and then it interacts with the human in the loop. Uh, that uh, that is required when some sort of critical decision is being made by the AI agent. So human in the loop can decide to approve, escalate, or override. So it's up to the human how he is going to deal with it. Fourth one is AI defense and response layer. Here we have, a bunch of other cool stuff: federated threat intelligence, explainable AI security insights, digital twin security, autonomous remediation, and post-quantum crypto. So federated threat intelligence, you will be fetching the data from the various sources, you know, and then we'll do some sort of intelligence and update the OOAD policy engine. OOAD is basically observe, orient, decide, and act. Explainability AI is basically whenever AI agent will make some sort of decision, it will try to explain why he have made that kind of decision. Two twin security, one is active, another one is passive. Active is only so this one is used for provide the security based on the telemetry data from the device at the layer one, and this one is to install to provide the security at the sandbox layer to make sure that whenever some sort of security patch is installed, device works normally. So post-quantum crypto is for future purpose because current cryptographic encryption can be broken by the quantum computer. So we need a strong mathematical quantum cryptography to protect that in future. The last one is the governance and compliance layer. Here we can see European Union AI Act, NIS, TAI, RFM, and all. So these are the kind of bunch of governance and compliance we apply at the last layer, and then we do a policy feedback loop to the upper layer to update the OOAD policy engine. So this is the extension of the previous slide. We are going to talk about zero trust plus AI aware security. Every layer has, oversight built in. So first layer, as we talk about the edge and device layer, it has TLS 1.3 over the air patching, device identity, network segmentation through the VLAN, and then the firmware integrity. So second layer was the zero trust network fabric, where we have NHI IAM, virtual TLS gateway, OODA policy engine, micro-segmentation, behavioral analysis using UEBA. Uh, AI agent orchestration layer, it has a multi-agent manager sandboxing, as we discussed, prompt guardrail, agent-to-agent authentication, and memory integrity. AI defense and response layer is for federated threat intelligence, explainable AI insight, digital twin testing, guardian agent, uh, post-quantum computing crypto. Then the last one, as I said, governance and compliance. Here are a bunch of governance from the different countries, European Union, United States, etc. Here we can see that, zero trust principle from autonomous system. What we do first, never trust, always verify. That is what the zero trust says. Least privilege for AI agent, provide the least privilege first, and then keep on increasing the privilege depending on your security requirement. Uh, Assume breach. So, always think that, breach can happen at any point of time. Human in the loop oversight. So, uh, if humans are involved, then we may expect that human may ignore some of the threats and can, approve the request from the agent. Continuous audit trial, we have to go through it to make our system robust. Uh, this is about, foundational paradigm shift, how we think about the autonomous system. So left hand side in the red, you see the old paradigm. Security added after deployment. This is the known one. Agent trust are trusted by default. That is, we call it implicit trust. No audit trial for autonomous action. Human oversight optional or absent. Governance as a compliance checkbox. Security teams solved from AI teams react to breach after damage is done. So this is what we the old model is. A new paradigm shift will be security embedded will be embedded from the day one design. Zero trust for all agent and devices. So we always authenticate the request. We don't trust that, devices will always be trustable. uh, Immutable audit log for every AI actions, human oversight at every critical decision, governance at core architecture, security plus AI plus DevOps convergence. That is the new field coming in, DevSec AI. Then we predict, prevent, and remediate autonomously. So these are in the bottom line, we see these are the five pillar implementation framework. First one is the visibility. Uh, Here we have, inventory plus uh, full inventory, like device plus agents, identity, NHI, IAM for every principal, detection, behavioral AI anomaly engine, response, human in the loop plus auto remediation, and then governance. So, innovation for human well-being, right? So uh, I want to take a moment here to make argument that we often get lost in the security discussing because they tend to focus on what can go wrong, right? So you see on the left side, health. So here is the key insight. We built with security, oversight, and accountability. Agentic AI becomes our greatest defensive weapon. Healthcare safety is the first one. We start with there. So uh, uh, agentic AI becomes our the greatest defensive weapon. We can say the same capability that makes it dangerous in adversarial hand makes it extremely powerful in the defensive hand. Second one, we talk about the industrial resilience. Uh, so here, self-healing industrial network that protects power grid and water treatment facility from the ransomware, automatically isolate compromised segment and reasoning, etc. We can call about. Guardian agent is all about AI monitoring. Uh, Guardian agent watching for hijacking, memory poisoning, tool abuse, etc. This is autonomous oversight that doesn't sleep, doesn't miss any pattern. The fourth one is the human empowerment. This is This empowers the human security team. It doesn't replace them. AI handles volume. Human provide judgment, ethics, and accountability. And that is the right division of the labor. Uh, Fifth one is the explainable AI. As we discussed earlier, it makes every security decision transparent, so that it can be it can be auditable and human readable. Uh, Last one, we will talk about the accountability architecture. This is a decentralized audit log, a smart connector for agent actions, ensure that every autonomous decision have a clear ownership. So this is the implementation roadmap we can follow inside the company, current company. We are following this roadmap from last 9 months. Right now we are at at the phase 3. Uh, Looks like it is going to take longer than 6 months. So phase 1 starts with discover and baseline. So you start, you start what you have, a full IoT devices plus AI agent inventory. Then you look at AI readiness security assessment, NHI discovery, tooling deployment, security baseline, and KPI set. In the phase 2, we do hardening and segmentation. Uh, Here you put your all IoT devices on different VLAN from the corporate laptop, deploy zero trust access control, then patch the critical firmware vulnerability, uh, you know, and do the agent sandboxing establishment. Phase 3 is the monitor and direct. Here, uh, Here we do the detection and monitoring, deploy AI specific SI, EM, and SOAR to the understood agent behavior, right? Continuously red team program, uh, real time agent traceability. And the fourth one is the governance. Here, AI governance and maturity program comes in. Let's say you are going to sell your product in different countries, so they will have the different AI governance rule. You have to follow that. Post quantum crypto migration, you have to be prepared for that. Automated response playbook and EU AI Act plus NIST RMF compliance. So these are the key takeaway. First one is the question is about trust, not just security. Here we build the system where people trust is required, embedding security, explainability, accountability from the design state, not as a feature. Second one is agentic AI plus IoT coverage creates compound risk with 18 billion plus devices and autonomous agent, uh, uh, bidding physical or digital world. Single compromise can cascade into the enterprise world. Third one is the traditional security controls that are built on the autonomous agent. Fourth one is the zero trust plus human in the loop wherever is mandatory. Fifth one is the security built-in enabled innovation. It doesn't constrain, right? So when the security is the foundation, AI can safely defend the IoT devices, medical devices, power grid, etc. Secure the system, earn trust. That is what I would like to say. Trusted systems serve human well-being. So yeah, so that's all about the presentation. Security is not a product; it is a philosophy built in. Give it oversight and let it serve people. So here is my email. Some of the here and also I have a scholarly article. Few papers I have on research paper I have on zero trust and explainability AI as a service. So please feel free to check out those paper from my Google Scholar. Here is one of the data sets I have trained for industrial anomaly using 5-3 model. And yeah, so these are the one. And here is my LinkedIn profile. Feel free to connect. And now it's time for question and answer.